What is this talk about? This talk is about actually a lot of the work that we spent time doing in Java E7. One of the themes of Java E7 is to enable these sort of applications, HTML5 rich client applications. So this talk is basically highlighting that work and telling you how it is that you can go about creating these applications that are sort of hybrid applications where you have a very JavaScript heavy front end talking to a Java E7 in the back end. Right. Moving forward, this is my sort of action plan for the next 60 minutes or so. I'll be spending a little bit of time overviewing the JavaScript HTML5 landscape at a higher level. The reason I do this is when I go and talk at conferences, what I often find is that people tackling this topic are sort of the JavaScript fanatics. You know, they don't actually kind of take a step back and approach the topic at a higher level with some historical perspective and in terms of context. You know, what are the other options available, and what are the pros and cons of this approach? I hope to not spend a lot of time doing that. I don't want to spend the whole time. I don't want to spend more time doing that than covering Java E7 in the end. So I hope to spend no more than about 10 or 15 minutes sort of surveying the landscape of JavaScript HTML5 at a high level. Then, of course, a majority of the time that I intend to spend in this session is talking to you a bit about what is it that Java E7 offers as a backend in this sort of architecture. And actually, a lot of this talk is code-oriented. I'll basically be showing you an application that I developed that I hope you will also take a look at to understand how do you approach this problem domain. So a lot of this code is actually, a lot of this session is actually about doing demos and taking a look at code to see how is it that the demo is working. All right. So let's start at the beginning. What is going on with this entire JavaScript HTML5 business? For most of you that have been in our industry for a while, you'll notice that this is not a new debate. In fact, in all honesty, this is a debate that is started from the very beginning of computing. We've sort of gone back and forth in the question of where does UI logic really belong. Back when we started this journey of computing in the mainframe era, really what you had is super thin clients. Okay, the clients were dumb terminals. They would render little more than colored text. Okay, and that's really all you get. You couldn't get any thinner in terms of clients. And really, the majority of the work, of 99.9% of the work, was really done by these big iron mainframes. We saw a 180-degree shift away from that because of the personal computer revolution. So certainly we had, with personal computers, we had a lot of computing power available to us in the client, and the client was relatively capable. Okay, so this is the age of things like Visual Basic. Perhaps some of you may have heard of this thing called Power Builder. Okay, so in this world, what you would have is very, very powerful UIs, very, very powerful desktop applications. In the first generation of these sort of applications, you actually didn't have any middleware whatsoever. These applications literally talk to the database directly from the desktop. Towards the latter phase of this era, you started to see the value of having middleware servers. So that's sort of the rise of the so-called, what we call today, three-tier architectures. So in this architecture, you'd have the client, it's still very powerful GUI-driven desktop clients. You would have some kind of middleware server. Typically the middleware server communication protocol would be something like DCOM or DCOM, or at a later stage, something like EJB2 remoting. And then these middleware servers would go and talk to the backend. Now, there's pros and cons of this approach, and it's important to understand these pros and cons in order to apply those lessons today. So the big benefit of this approach is that you had very, very good user experience of the software. In fact, I would say that we have still yet to rival, the usability, the end user usability in enterprise applications of that era. The big downside of this approach was it was very, very demanding in terms of maintenance of the client. Your client needed to have good enough hardware, good enough systems to be able to run these clients, number one. Number two was any kind of maintenance was a big nightmare. Okay, if you even wanted to push a small update, well, guess what? You'd have to go and find every single of your clients and persuade them to upgrade their client UI software. Extremely painful process. Largely because of that last pain point, what you saw then again another 180-degree shift. With the rise of the browser and the rise of the internet is where we are today, namely largely server-side applications. And this is very much what most of you are probably doing today. So if you really think about it, this is really nothing much more than largely a reversion back to the mainframe era. Okay, so really your dummy text-based client is replaced by sort of a weak, okay, not very powerful GUI client in the browser. Okay, the browser is not capable of doing very much, but it is capable of at least giving you a modern-looking UI that has modern UI widget sets. And again, by and large, majority of the processing capabilities, even aspects of the rendering of the client, is really being handled by none other than the server. Okay, in this case, probably a large server farm rather than a single big monolithic mainframe application. And that is, as I said, a good example of this sort of technologies are the cutting edge, really the cutting edge, and the mainstream technologies today. So these are the JSF Struts and the Spring MVCs of the world. I bet most of you are using one or more of these technologies. Now, a little bit more of recent history. A few years ago, about 10 years ago now, there was a new buzzword called Ajax. Okay. So the big promise of the Ajax, I hope some of you remember this, was that we'll turn the browser into the desktop, into the equivalent of the desktop client. Okay, so we won't write anything more on the server side. The server side will become sort of the middleware servers that we had in the 80s, and the browser will take on the heavy lifting, equivalent to what we had in Visual Basic and Power Builder of the day. Okay. The reality, though, is that has not occurred. Okay, Ajax did not kill off the JSF and the Struts and the Spring MVCs of the world. Rather, what happened was you saw an incorporation of Ajax techniques into these server-side frameworks, and by and large, they're really a second-class citizen of sorts in otherwise server-side frameworks. So example of this is prime faces. Okay, so if you're writing a JSF application, in all likelihood, you're probably using a widget set that uses Ajax under the hood. But you, as a server-side developer, are by and large are unaware of this. Okay, Ajax just is a plumbing layer for you, and you are by and large writing a server-side application. Same thing with GWT. Okay, again, the only difference here is that you're even at a higher abstraction level. You're not dealing with any kind of browser code whatsoever. You're writing Java code that gets translated into JavaScript at runtime, and that JavaScript happens to include some Ajax stuff. Again, you're largely unaware of that. If you are using something like Spring MVC, yeah, you're probably more familiar with what is going on under the hood with Ajax. You're probably muddling around with something like Dojo or more likely jQuery. Okay, but again, by and large, if you were to describe yourself, you're probably mostly writing a Spring MVC application with some bits and pieces of Ajax here and there. So, in fact, if Ajax did not take over the world, then why are we essentially revisiting the same rhetoric, the same sort of ideas today? Okay, if you listen to the people preaching about HTML5 JavaScript clients today, their message is very same, exactly the same, the message that we heard 10 years ago with Ajax. So what has changed? Okay, why are we hearing this now? Well, the truth is there are some legitimate legitimate reasons why this is the case. Some things have changed. The big thing that has changed, if any one of you who have actually tried writing a full-scale Dojo toolkit application, is JavaScript Performance. Okay, anyone that tried to do that 10 years ago, you're in for a lot of pain, because in reality, these JavaScript engines really weren't that performant. In fact, they aren't even today. Okay, so even if you look at, in particular, Internet Explorer today, Internet Explorer's performance has improved. I would say even significantly, but still, it's not as fast as a compiled language. It's nothing approaching certainly the level of a Visual Basic or a Power Builder native application running on the desktop. But it has improved. So there are improvements in things like V8, the V8 project for Chrome, and the various monkey projects for Firefox. But again, this is not entirely true. It is an improvement to a degree. The other thing that has happened is, because of the pain experienced in the last 10 years with trying to make Ajax work, a few of the things that has come out of that experience is better tooling. Okay, jQuery is a big one. It almost makes the most painful part of Ajax development, which is DOM manipulation, mostly go away. Okay, there's still some corner cases where that's not true. However, it's leaps and bounds better than what you had 10 years ago if you are just trying to use something like Dojo, for example. The other thing that has happened is the so-called MV star framework. So what are these? These are the AngularJSs of the world, and the React JSs of the world, and the like. And fundamentally, what do these do? And I'll show you a bit of AngularJS code in this application, if you haven't seen it before. What these do is that they bring sanity into the JavaScript code. If you're dealing with prime faces or JSF struts or the Spring MVCs of the world, these are architecturally sound technologies. Okay, they implement a specific design pattern named the MVC. The reason, and because this exists, you're not sort of going insane writing these UIs. Your UIs look fairly structured. Structured bit of code. And what these MV star frameworks in JavaScript do is that they replicate those exact ideas. Okay? They replicate the ideas of bringing the concepts of MVC into this JavaScript world. It helps you avoid a simple term called jQuery soup. Anyone familiar with that? It's large blocks of JavaScript that are sort of spaghetti code that has no structure whatsoever. Okay? Lastly, the other very important thing that has happened is better development tools on the browser. So let's think about, again, back to the Java world for a second. So if you're a Java developer, you don't just get an IDE or a text pad. You get much more than that. You have compiler support, debugging support, profiling support, error consoles, and the like. Okay, these were virtually non-existent in the JavaScript world even 5 years ago. All you had was a little JavaScript console. That's it. Okay, if you're lucky. That has improved now. Okay, so if you go onto the development tab of something like a Chrome browser, you will see equivalents of debuggers and the like. Okay, so this is again is important, and especially from my standpoint, the biggest thing that has changed is that the ecosystem, the standards-based ecosystem, the tool set, okay, the basic API that you will use on the browser, that is finally moving forward. Okay, so you are seeing things like HTML5, you are seeing things like CSS3, you are seeing things like WebSocket, which I'll briefly talk about. And that is important. If the API isn't there, it's meaningless, right? So the API advancement is also probably the most important characteristic why people are sort of repeating that same Ajax message. Okay. Now, here's a big $1 million question. Is it a slam dunk? Should we buy into these sort of people that are telling us, well, let's forget about these server-side frameworks and let's develop everything in JavaScript with this new renewed tool set? I think the honest answer is maybe. Okay, so there are some things that these sorts of clients are very, very good at. No question about it. Okay, so they are good at a class of applications certainly that are sort of highly dynamic, interactive. There's a lot of interactivity going on a small scale in a small form factor. They're relatively complex, feature-rich UIs, again, very dense UIs. And they sort of fall into this acronym called single-page applications. It's a single screen that has multiple views, okay, multiple incorporated views. It's a little bit easier to understand. Well, it's easy. It's very easy to understand if you ever develop an applet in your life. Okay, it's basically exactly the same problem domain that we were trying to solve with applets. Okay, about 15 years ago. However, if you're not familiar with that paradigm, here's a couple of simple mental models. One is your typical desktop application today, okay? And there aren't a whole lot of those anymore, okay? So these would be your document editors, Microsoft Word, Microsoft Excel, or perhaps something like an image editor, like Adobe Photoshop, okay? If you were to write those on the browser, well, guess what? It's a good problem domain to solve with JavaScript clients. You need that rich UI functionality because you have all the characteristics that fit, okay, that problem domain. Number two is your typical mobile application. Again, these are relatively small. They have small form factors, and they're relatively complex. Okay, they have a lot of things going on in a very dense space. Again, a good clear use case for these sort of JavaScript HTML5 rich clients. However, the reality is, even today, a large portion of our applications do not fit those categories. Okay, by and large, what we develop as server-side developers doesn't sound glamorous, but it's the truth. Nothing much more than really a next generation of newer looking, fancier looking mainframe applications. Okay, what are these? You'll figure this out if you actually look at a mainframe application. A typical mainframe application is a set of interrelated screens, okay, and really deeply nested workflows. Okay, you do thing X, and then there's step 1 to 3 where you need those steps. You need that workflow to be executed, and it's a collection of distinct pages that are interrelated but are distinct pages. Okay, they're distinct workflows, distinct paths. A good mental model is your average website. Okay, so you have breadcrumbs, you have sections in your page, you have an order section, you have an account section. Each of those screens taken on their own are not complex. Okay, however, they are bound together in complex chains and complex navigation rules. Those are not good fits. Okay, not perfect fits for the single page application paradigm. The single page application paradigm will work against you in those cases. It will not work for you. Okay, the other thing is server-side applications by and large do have some strong points. Okay, so one of the big benefits is control. Okay, you are not really dependent. You don't have to worry about what is running on the client that much. Okay, because by and large, your computing capabilities are on the server side. You control what the hardware is. You control how much bandwidth is required. Your requirement on the client side is very, very minimal. All right. It's better for reliability for those same reasons. It's better for security for those same reasons. Even boring things like accessibility and search engine optimization, those are all solved problems and well understood problems that have been solved for a long time in these server-side frameworks. It's not that these new frameworks do not solve these problems. However, they're still at a relatively immature state. Okay, in order to solve those problems, and hopefully they'll get there. Maybe they won't. Who knows, right? But regardless, these are today strong points of server-side applications. And let's face it, JavaScript HTML5 development is not without its pains. Okay, because the reality is, however you slice it and dice it, something like JavaScript and HTML is just not on par, okay, in terms of development tools and in terms of feature sets with a first-class programming language like Java or Scala or what have you. Okay, by and large, you really need a different mindset. Okay, to develop in this with these sorts of clients. The other thing the other point I will make for you is this last one, and a very interesting one actually, one that I didn't expect myself, but I've learned it as I've done this talk, and I've been doing this talk for about an hour and a half. Sorry, a year and a half. Let me prove this point to you, right? And I want you to really think clearly and be honest with yourself when you answer this question. You're going to exit this room, okay, in about 35 minutes, 40 minutes actually. As soon as you get out of this room, you are no longer allowed to touch anything like JSF or Spring MVC or GWT or whatever you're doing today. No more of that, okay? Your entire toolchain will consist of HTML, CSS, and JavaScript. You are terribly excited about this prospect. Remember, you have 40 minutes until the end of your JSF or Spring MVC or GWT life. You're excited about this prospect. Okay, 1 and 2 and okay, it doesn't count, man. You get 1 vote. That is in this room. That's less than 5%, well below 5%. Okay, why is this? It's important to understand this. Why are we not excited about this? The real reason we're not excited about this is because the server-side frameworks, as limited as they may be, has served us relatively well. Okay, we've written successful, commercially successful, and business-wise successful applications with these. Okay, they're not perfect, but they do the job. All right, and they're relatively painless to develop with. Okay, you're not encountering a lot of pain on a day-to-day basis developing this. Okay, that's why you're not raising your hands. However, the reality is still, we do have 5% of the people raising their hands, and this is in a Java-centric crowd, to be very honest, right?
I can say I spent 10 years in JSF until I learned JavaScript.
Okay, so the reality is that there is, if I go to a different crowd, let's say I went to a Node conference and asked this question. Well, guess what? Probably about 90% of the people there will raise their hand and say, yeah, we're very excited about this. Okay, so the reality is neither black nor white. It's somewhere in the middle. All right. So I very much doubt we'll see the fruition of these sort of people that are prophesizing that we're all going to be doing this. I don't think so. Okay. What I do think is that this is going to be an important part of our tool set. Okay, just like we have a lot of diversity in server-side Java in terms of the tools that we have to that we can choose, I think this is yet another tool for us, and I think that's the real truth behind at least five years from now. I can comfortably say, okay, maybe even 10 or even longer term. Now, the other thing, the server-side guys, you should caution yourself is that don't put yourself in a box either, because even in your applications, okay, there could be sections of your application that fit these paradigms, these characteristics quite nicely. Okay, it's very similar to how you use Ajax today, right? You have a largely server-side application, but you have certain parts of your application where you're using Ajax. And this could be a very similar situation. Or perhaps you're asked to develop a mobile version of your application. And again, this is a tool chain that will be handy for you. All right. So moving on to how you do this, from why you would want to do this, or if you would want to do this. The nice thing here is that we already know a lot of these answers because we've learned these lessons. We've seen this exact dynamics, especially in the 80s. Okay, and we can apply those lessons almost exactly here. So in this sort of architecture, the client layer is responsible for things like UI rendering, obviously, right? Showing you what widgets you should be looking at. Basic input validation. Okay, this is not business logic validation, but simply data validation in validating that you're getting the right input from the user. some UI logic, not business logic, mind you, UI logic, meaning, okay, what screen do I need to show next? Do I show this field or not? How does this field look like? Okay, these sort of things. As well as by and large state. Okay, you're going to hold state principally at the client side. Again, we know this because we did this once before. The server, on the other hand, would be responsible for the things that's more logical fit for the server. Okay, so these are things like business logic, transactions, your domain model, persistence logic, security, scheduling, messaging, and all of those other things that are simply not possible or not even ideal. You wouldn't want to do these things in the client. Okay, so there's a clear separation of concerns. Okay, okay. So in this case, okay, the glue is HTTP. Right, so you're going to HTTP is going to be your communication protocol between the client and the server. Now, what flavor of HTTP is another question, okay, and it's an important question from a server-side development perspective, certainly. Again, we can apply the lessons that we already know of this architecture. By and large, we'll be using REST. Okay, why will we be using REST? Well, as it so turns out, even in the 80s era, the way the client-server interaction worked is very idempotent. Okay, so you would do one thing, it would cause a state change on the server, and the next request you make really has nothing to do with the previous state change. It's just unit actions, okay, independent unit actions that you take, and that's REST. Okay, that's basically what you use REST for. There will be a subset of problems where that is not enough, where you will need stateful, bidirectional, full duplex communication. Okay, and the problem and the tool that you have to solve that problem is WebSocket, right? And that is actually something that was added as part of the HTML body of standards. And by and large, the data format that you'll use in terms of interchange is not going to be XML. It's going to be JSON. Okay, if for no other reason than for the very reason that it's extremely easy to process on the server side. Right? You're in JSON. If you're in JavaScript, if you're receiving JSON, it's the native serialization format. You don't need to do any additional processing to do that. There's other good reasons to use JSON as well that I won't get into. Now, namely, these are basically JSON is a lot more compact and hence much more bandwidth friendly. Okay, so it's a sensible protocol even from that standpoint, as well as the fact that JSON by and large is a simple format to process. Okay, it doesn't take either a lot of memory or CPU. Basically compared to any other alternative other than raw binary. Okay, and it happens to be ASCII, which means it's cross-platform. Okay, which is always a very nice characteristic to have from a data format. All right. So next thing is, well, why Java EE? Why would you want? What does Java EE offer? In this sort of architecture? And the answer is, it provides you pretty much everything that you need. Right. So the three fundamental building blocks out of that you must that any good server side must have to support this sort of architecture is REST. Okay, and Java EE supports that very well with JAX-RS. For the corner cases where you need WebSocket, well, Java EE, we've added a new API called Java API for WebSocket that allows you to create WebSocket endpoints quite easily. We've also added first-class support for JSON, okay, through the Java API for JSON processing, and we'll improve that even further with adding a binding API in Java 8. And of course, the rest of the problems, okay, that you're going to solve in the server side, those we've already solved, right? Those we already solved well. So these are things like transactions, persistence, messaging, and a very nice one actually that I'll show you is bean validation. It becomes even more. It used to be a nice API anyway. It becomes even nicer with these REST and WebSocket endpoints. I'll show you in code examples why that is. Okay. So the best way that I could introduce this material to you in terms of showing you both how it can be done and what Java EE offers in doing this is by code example. All right, and this is the code example that I have. I actually wrote up an example application for both sides to take a look at. People that are coming from the JavaScript HTML side and taking a look at Java EE, as well as from the server-side Java developer standpoint to see how does the integration look like from the server-side standpoint. I don't actually plan on exploring all of the code. Okay, I'll actually be focusing on the simpler problem, which is REST. Okay, as a homework, I'll let you see how the WebSocket problem looks like. I'll introduce the WebSocket portion of the demo, but I won't actually show it to you. I'll just focus on the REST portion. All right. So rest of the time, I need to sit down and show you some code and show you some demos. All right. Here we go. And we're actually doing okay on time. All right, so I have this example application. It's running on GlassFish 4.1. It'll run on any Java E7 compatible application server. I'm running on NetBeans, but it doesn't really matter. It's just a Maven project. You can run it on Eclipse if you so wish. All right, run my application. Okay, so the application itself is very, very self-contained. If you go onto the GitHub, it'll show you how to set up this application and run it on your own machine. All right, I've set up step-by-step instructions. But this is how the application looks like. It's actually two different applications, and I've chosen the examples very, very carefully. For the REST case, where you're using REST in the backend, I've chosen ToDo. Okay, and the reason I've chosen this is every single Hello World JavaScript framework that you see, they always have a ToDo example. Okay, and ToDo actually happens to be a nice example. It shows you the sort of the strong points of REST and how you would go about doing that. Okay, because it's CRUD, it takes you through the entire logical lifecycle of operations. The other example that I won't go into too much detail is chat. Okay, and that's showing you how you would use WebSocket. Okay, on the back end. And that again is a carefully chosen example. If you look at any kind of WebSocket tutorial out there, by and large, they'll start with chat. And again, the reason they choose this is because it's a nice example, okay, that shows you an entire logical cycle of operations. All right, so we'll start with the ToDo interface. Okay. The reason I'm getting this is because I'm using SSL. Notice the access is HTTPS, and I'm using a fake certificate. Okay, on GlassFish. That's the whole reason I'm getting this error message. I'm going to proceed. Okay, notice that I am getting a authentication dialog. Okay, so this is a secure application. I'm logging in. By the way, I'm logging in onto the server side. Okay, that's where the security is taking place. So here I go, basic auth. There's my username, and I've logged in. Okay, there's my ToDo application. Nothing too fancy about this. Okay, it's very basic. So let me do some CRUD operations. If I can type today, that is. That's the create portion. Okay, and just to show you that we've actually gone through a database round trip, I'm going to shut down the browser. I'm going to restart the browser. I'm going to put in my ToDo application URL. Advanced. I'm going to log in as the same user. Okay, and there it is. Okay, so it's saved in the database. If you look in my logs, you'll see, if you have very good eyes, you will see these insert operations taking place. Okay, so this is database round trip has already occurred. I'll do a modification. So let's say cook dinner later. Okay, I can do a delete. So let's say I delete this, and I can also complete. All right. So basically, I've just gone through the entire CRUD cycle with you. All right. Notice the characteristics that fit. Okay. That our JavaScript HTML5 characteristics as well as REST characteristics. These are all unit operations. They have nothing to do with each other. Okay. You take one action, you're done. All right. The other thing is this is a relatively compact space. Okay, there's not workflows going on. So I'm not transitioning to another view within another UI structure altogether. Okay, I'm staying largely within the same UI structure. I'm just altering parts of it. It's relatively dynamic. Okay, certainly there's no page reload or anything like that. As soon as I'm doing something, it's changing it. It's relatively dense. All right, so I have this entire CRUD operation in the space of a very small space. Right, so this is a good use case for an HTML5 rich client application. It's definitely a SPA, a single page application. All right. So how is this occurring on the server side? So now let's take a look at some of our Java EE code. So I've organized this code relatively logically, I hope. Everything in To-Do is in the To-Do package. When you explore this code yourself, you'll see it. So let's take a look at, well, what work do you need to do in order to create a REST resource in Java EE? Well, nothing more than, just like everything in Java EE today, just POJOs and annotation. There's no configuration. Okay, so if you look at my Maven file, I'll show you how my Maven file looks like. Here's my Maven POM. Okay, my comments are bigger than my POM file. Okay, so really the only dependency I have is the Java EE API and just two Java EE dependencies, and all of them are provided. All right, these are all provided by the GlassFish runtime, and this is it. Okay, there's no other configuration. If you look at my web.xml file, this is how it looks like, and by and large, it has to do with just security. All I'm doing is securing the application, right? Just configuring Java EE security. Other than that, really nothing much at all. There's no other configuration, believe it or not. You just write this POJO, annotate it, deploy it in your WAR file. Lo and behold, you're done. Okay. How do you create a REST resource? Well, it's simply you specify this @path annotation to say, okay, please publish this POJO as a REST endpoint. My URL happens to be to-do and username is a path parameter, okay, meaning that it can vary. Okay, so if you look at I'll show you my URL later, but the URL I'm accessing is actually /todo/Reza, okay, and Reza is a parameter, it's the username. Okay, it could be to-do/John, okay, and JAX-RS will allow you to do this. I'm injecting a to-do service. This guy is who's doing the heavy lifting of the database interactions. So any business logic and the like would be under this to-do service facade. And I'm simply mapping a bunch of HTTP actions here. Okay, so I'm mapping the post action. Okay, if you do a post against this endpoint, it will create. It will go to the create method. It will invoke the create method for you. Similarly, if you do a put, okay, it will automatically map to the edit method via that annotation. Delete, the HTTP delete method will map to remove, and get will map to the get all method. That's what I'm initially doing to get my list of items. I won't show you all of this. I'll just show you a representative one. I'll show you the put operation to do an edit. Okay, let's see how it looks like in Java EE. I think it's as simple as you can possibly imagine it to be. All right. So to get to this edit method, the full path that you must follow is to-do username / the ID. Okay, which to-do item are you editing? And that is what this path parameter is denoting. And it also has an ID. It takes an ID as a parameter. So it would be to-do Reza 1, 2, 3, 4, 5, 6, 7. Okay, the ID of the to-do item that you're editing at the moment. It consumes application /JSON. All right, and believe it or not, this is all you need to do. Okay, for you as a Java EE developer, really, JSON is nothing much more than another Java serialization format. Okay, as soon as you say application /JSON, JAX-RS will do the parsing for you. It will take the JSON input being received in the post method. It will do the parsing for you, and it will hand you a nice little to-do item POJO. Okay, this is it. Right, that's all that there is to it. but you can do more. Okay, so for example, in this case, I'm taking the username as a parameter. Okay, so I'm pulling that out of the path, and that's what that path parameter denotes. Similarly, I'm pulling out the ID, okay, and that's that's a part of my path as well. Similarly, you could process query parameters, cookies, whatever else you need to do. It's all just a matter of placing a few annotations to say, hey, please map this value into this Java object for me. You can do even more. You can validate the values of this. Okay, so I can say, using bean validation annotations, I can make sure that the username is not null. I can make sure the username is between 4 and 14 characters, and so on. And all of this validation, as soon as you put this on here, will be done automatically for you. If any of this validation fails, you don't do anything. The runtime will generate an appropriate error with an appropriate error message to the client for you. Okay. You can even validate the inbound body, the to-do item. Okay, and the way you do that is you simply put in an add valid annotation. And what does this do? It looks into the via reflection into this object itself. Okay, so in this object I have an ID, a username, and a description field and a completed field. So those are the fields that you're seeing in the to-do application, for example. Okay, each of these again can have bean validation code in them. Okay, let me show you this bean validation code in action. So here's my, notice that the description field must be between 5 and 110 characters. Okay, that's the validation rule there. So I'll go and try and enter something that is 2 characters. Okay, that's the validation error message coming from the server. Okay, and I'm just rendering that error message on the client. So again, the bean validation API becomes very, very important. You weren't able to do this thing in Java E6. Okay, as of Java E7, you can actually apply bean validation rules to method parameters as well as return values. All right, it comes in extremely handy in terms of validating remote input. If you've already probably also noticed that the to-do item is actually a JPA entity. Okay, so this reduces boilerplate even more. I'm simply manipulating the exact entity that I'm saving in the database right here. Okay, so this entity maps to the to-do item table. Other than that, it's really just setters and getters, nothing much more. I don't want this value to be sent out, so I'm marking it transient. Other than that, it's just, again, simple getters and setters. Let's take a look at the service method now. So let's take a look at this guy. This is the interface. I want to go to the implementation. I'm sorry. Okay, and in my case, it's very, very simple. All I'm doing is some simple data manipulation in the service method. Potentially, this could be a more complex facade. Okay, if you have a complex domain model, this is what you would put in here. I'm doing some simple logging. Okay, and I'm simply calling my repository method to do an update. Okay, please update this guy. My repository is being injected here. Okay, to-do item repository. If I look into this guy, navigate, open implementation, default to-do item repository. This is again just a POJO. All right, nothing much more to this. This guy happens to be an EJB, by the way. It's a stateless EJB. So all of these methods are transactional. They're monitored on the app server. If you open up the app server, you'll be able to see there's a monitoring tab for default to-do service. You'll be able to see things like how many times this method succeeded and failed, what the average response times were, so on. You can secure this if you want. This is just a POJO. It's not an EJB. And all it is, it's a facade over the JPA entity manager. So create method is simply entity manager.persist. In fact, if you really wanted to, you could generate this DIO portion. Okay, you can either use NetBeans generators or you can use a module called delta spike query. Okay, it will automatically create the repository portion for you. So all you really have is this repository code. Okay, so it doesn't get any more simpler from a Java E side, and a lot of functionality that you get out of it. So now let's take a look at any questions on the Java E portion so far before I move into the JavaScript portion. Yes. So the reason I did that is because I actually want to support both data formats. So I want to support XML and as well as JSON. A very nice feature that's included in GlassFish is that it uses Moxie, a project called Moxie for JSON serialization. So you can actually use the same set of annotations for both XML and JSON. Okay, XML transient also applies to JSON as well. So that will not be published out. Okay, any other questions on the Java EE portion? All right, let's move on to the AngularJS portion as well. So I sort of chose AngularJS arbitrarily. Okay, you can use any JavaScript framework here. The basic concepts are going to be essentially the same. Certainly the server-side portion is going to be exactly the same. How the binding is done on the server side, on the client side, is going to be slightly different, but very, very similar. Okay, so let's start taking a look at this Angular JS application for the sake of it, and let's see what we can learn. Okay, so in order for something to be an Angular application, you have to declare it as ng-app, and you can declare it at any point. I decided to declare it right in the HTML tag. Okay, there's actually a corresponding application definition that maps with this ng-app name. I'll show you that in just a second. If you look at my what I will call the import section, there's a couple of different things that I'm importing. So I'm importing Angular min, which is the core of AngularJS. It's just the MVC portion. Okay. I'm also importing something called Angular sanitize, that little bubble that I showed you. Okay, as the error message that uses Angular sanitize. All right. And finally, there's this Angular resource. Okay, and what is that doing? Besides providing you the core MVC framework, Angular comes with a set of useful utilities. And one of the most useful ones is this Angular resource utility. What is that? It's a very, very simplistic and powerful API to do REST bindings, to bind to any given REST endpoint. All right. That is it in terms of my imports, so to say. Now comes the modularity portion. Okay, so notice these 4 files: controllers.js, services.js, directives.js, and application.js. This is the whole reason you would want to use an MV Star framework like AngularJS. If you didn't have this, what you would have is called what's called jQuery soup, which is a large block of JavaScript that does a whole bunch of crazy stuff. Okay. Now, if you're very clever, you try to modularize and massage that jQuery code to make it look like MVC, but why would you? Okay, so that instead you would want to use something like AngularJS, which forces the MVC structure on you deliberately. So as you can see, these are the way your application is structured. First and foremost is the controllers, and controllers is will look very familiar to a JSF developer. Okay, a controller is nothing much more than a model, a representation of the data that you're going to bind from your view, as well as any action handlers. Okay, so if you were, for example, in my case, an action is adding a new entry. When I hit enter on the text field, that's adding a new to-do item. Well, you need to bind that action to a controller portion. Okay, so that's what the controller is. Services is very similar to the remote proxy pattern. I hope some of you are familiar with what the remote proxy pattern is. The remote proxy pattern is basically the heart of your business logic. Okay, what are the actual functional things that you're doing with this application? That's where what is going to be in the services. All right. In this case, the services is really nothing much more than a facade over your REST bindings. That's where the REST binding invocations will actually occur. Okay, that's why it's very similar to the remote proxy pattern. Directives I won't go over too much. It's too complicated for the purposes of this. Very briefly, I'll let you take a look at it. The purpose of a directive in AngularJS is to keep your DOM manipulation code separate from your business logic. Okay, wherever you do, you're trying to manipulate DOM by hand. Okay, you segment that code out in as a directive. By and large, AngularJS will actually handle the controller portion for you. Okay, anytime the DOM needs to be updated, AngularJS will do that portion for you. I'll show you how in just a second. And finally, there's this application component, and that is what wires together the entire thing together. Okay, it is where you bind together the controllers, the services, and the directives. Okay. Finally, I am binding the controller. Okay, the guy that is again the representation of the data and behavior of this method. Okay, with the body. You can bind it anywhere. In this case, it made sense to me to just bind the controller to the body itself. We'll take a look at the controller in just a second, but I'm opening that up right now. I won't show you the rest of this code. You can take a look at this by yourself. I'm just going to focus on one field, okay, and that's the field that I used to enter the new field, okay, the new to-do item. This guy over here, where my focus is at the moment. So this is nothing much more than a form. Okay, notice that on form submit. Okay, which means when I hit enter in that text field, the action that is taken is add item. Okay, that's a controller binding. The add item method is actually defined here in the controller. All right, so if you look at the controller, here's the controller. The controller has some values, but there's the add item invocation. This is the guy that's invoked when I hit enter. Okay, you'll also see that there's this field called input. Okay, this is my input field. It is bound to a model called new to-do description. Okay, so there's a JavaScript variable on the controller called new to-do description. Okay, and if you look up here, there's the new to-do item description field. Okay, so what happens here is when I hit enter, AngularJS automatically binds whatever value I entered here into this JavaScript variable. And vice versa. When I change the value of this JavaScript variable, that is automatically reflected on the UI, just like it is in a framework like JSF, for example. Okay. So in this in this add item method, I create a to-do object. Okay, this is my domain object, if you will. It is inline created using JSON. Okay, so I just need really one field description, and it will take the description of my new to-do item. And other than that, I simply call item.save. Okay, and this will result in a REST request being made, a post request being made against the server side. Well, how is that happening? The way to understand that is taking a look at this to-do object. All right, so let's take a look at the to-do object. Okay, for some reason that's not working, so I need to open it up manually, which is relatively easy to do. It's JavaScript to-do services. Remember, this is my remote proxy. Okay, and this is the definition of my to-do object. Okay, to-do domain object. It takes the Angular resource library as an argument. Okay, that's how you define a dependency. So essentially, in effect, the to-do object extends from this resource object. And the resource object is really nothing much more than a high-level abstraction, okay, to do REST invocations. Okay, you just feed it some parameters. So the parameters you feed to the resource object is the URL that you're connecting to. In my case, it's localhost port 8181 JavaScript, resources, to-do, user ID parameter, and item ID parameter. So just like I have parameters on the server side, I can have parameters here as well. Okay, so this is the URL I'm generally invoking too. Here's how I'm populating those parameters. Okay, so the user ID is set to the principal, the person that logged on onto this application. Okay, and the item ID is actually pulled from the JSON body. Okay, so when I say item.save, okay, that will have a JSON that will result in a JSON payload. In the JSON payload, I will look into the ID field. Okay, when on the post request, it will be null. All right, so there wouldn't be an ID field, just like we saw on the server side. However, if we were doing an edit, okay, and during the edit call, there will be an ID. So the ID will be pulled out from here and populated as part of the URL. The last one is a little bit ugly. Okay, so I'll explain to you why I'm doing this last portion. In this last portion, I'm asking the Angular resource template to override its values. Okay, so why am I doing that? So the reason I'm doing that is for some strange reason the Angular guys decided that both update and add map to a post operation. Okay, and that's not really correct. Okay, if you look at the REST literature, and add is supposed to be a post. That's fine. And edit is really supposed to be a put, not a post. All right. So over here, I'm just telling Angular resource library, hey, please don't do that. You know, if I do an update, please do a put for me instead. Either way, it's not a problem on the server side, right? In the server side, you can map a single method to both a post and a put, and you can programmatically handle to say, okay, did the client ask me for an update or a delete, right? You can do a lookup to say, hey, does this thing have an ID or not? If it has an ID, then it's an update, otherwise not. Okay, and that is it in terms of what you need to do. So that is as easy as the binding gets. Okay, and it's very, very similar whether or not you're using AngularJS or not. Pretty much every single JavaScript framework has these same sort of concepts. They have a concept of being able to organize your code. They have a concept of how do you bind to a backend REST service, and it's very, very transparent. It doesn't really matter what you're using in the end, okay? Whether you're using JAX-RS or what have you. But in JAX-RS, of course, you can do it quite easily. Okay. Now here's the homework portion. Now I'm going to show you the WebSocket portion of my application. So let's take a look at this guy. Open this application up. I'm going to open up the chat interface. Remember, this is the other separate interface that I have altogether. My browser is too maximized. I need to minimize it. Okay, so I will enter hello here. Okay, not a big deal, right? You could do this using REST, couldn't you? Right? Right. You do a hello and then I get a response back. Nothing too exciting. However, let me open up another browser instance. And okay, here we go. All right. Continue with this website. In this case, I'm going to log in as my wife. Okay. And I have the same problem here. I need to zoom to 75%. I hope that's not too small. Actually, let me zoom to 90% maybe. Zoom in. Okay, that's better. All right. Now I'm going to say, still not a big deal. However, right? And let's do here. Okay. This is no longer REST. Okay, you couldn't do this in REST very easily. This is where WebSocket is coming into effect. What's really happening here is that there is a WebSocket endpoint, a shared WebSocket endpoint between these clients. Okay, both of these clients are separate browser instances, separate clients connecting up to that shared WebSocket instance, and they have full duplex connection, their own connections. Okay, to the same endpoint. As a result, when I'm entering a message here, that message is going to the server. The server is doing some whatever calculations it needs to, and it's sending down that same message to all of the connected clients. Okay, so being sent from the client and being sent down to the client. Same thing on for all clients as well. Okay, the client that I sent the message from, well, he or she can also receive messages proactively from the server side. I'll let you take a look at that. That portion of the code will show you how the WebSocket code in Java EE looks like. Again, very, very simple. Couldn't get any more simpler. It's just POJOs and annotations and a relatively high-level API. Okay, I have just 1 minute. I will take any last-minute questions. Other than that, I'm looking to wrap this up. I will just show you the summary. Not too exciting, I think. But the resources, if you're learning AngularJS in particular, the best place is AngularJS.org. Actually, this is the easiest framework that I found, was the easiest to pick up, the most well documented. In terms of Java E, use the official Java E 7 tutorial. It'll talk about all of the things that we talked about: REST, WebSocket, Bean Validation, and all of the rest. If you're the kind of person that likes to learn by doing, there's a few resources here for you as well. Very basic tutorial, hands-on lab that'll take about 8 hours. I'm actually doing the hands-on lab as a workshop on Thursday at DevOps Poland. Or Cargo Tracker. This is a project that I maintain. It's about 10,000 lines of code. It'll show you how a realistic Java E7 application might look like in terms of development experience as well as features. And of course, the rest, I always like to point out the Aquarium. It's a blog that I and a colleague of mine maintain. It's a daily blog where we talk about something about Java E. All right, very good. I will take any questions. Otherwise, have a rest of the good afternoon, and I will see you hopefully tomorrow or at a later point in time in DevOps Poland.